All right, so again, this will be uploaded later to YouTube and you'll have it available. But you should still take good notes, of course. But we were not able to stream today on first day because, of course, the entire network at UNL had to go down. I'm Dr. Chris Burke. Some of you may have known me from previous semesters. Most of your faces are going to be new because last year there were only a handful of people that came in person, and even then, you know, almost everybody here has masks. I've been fully vaccinated since April, but I'm still wearing it because of the pandemic, you know, the Delta going around, and of course I've got 2 small children that are not yet able to be vaccinated. So keep that in mind as you're going around campus, and make sure you're washing your hands and other things like that. So again, remember that we are recording, and this will be up on YouTube later today. It depends on when I get my network back, right? Today is just going to be a course introduction along with kind of a review. Don't hesitate to raise your hand and ask questions as we go along here. I'm going to have to do everything offline here, so I'm not going to be able to do everything I wanted to do, of course. But I was able to, you know, pull up the front page of Canvas here. And you'll see that the schedule is already, you know, pretty much well mapped out. I've done this course now for 10 years, mostly in the summer. This is the first time I've done it in the fall semester in a long, long time. But I'm looking forward to the opportunity because usually in a 5-week summer course, we go 3 times as fast. It's also been online mostly for the last couple of years. So this will be the first time I've done it in a full academic semester. And that allowed me to take these big assignments that I usually give over the summer, these 4 big assignments, and spread them out over 10 assignments. That's not to say that there isn't just as much work as there would be in a regular summer. Of course, I don't cut corners in the summer, but there are 10 assignments. They're all ready to go. You can see here that you have one due about every week or so, right? And all the way to the end. The last one, of course, is due during dead week. That's the final. Final day. You'll note here that I put the final exam here, but we don't have any exams. All of your 100% of your grade is based on these 10 assignments. 10 assignments, 100 points each. The last one is based on, or it does have some bonus points available, but for the most part, that's it. There's no quizzes because there's no recitation with this course. There are no exams. That's something I have during the summer, but I decided, since this is an honors course, to cut those out. And so we just have these assignments. That should tell you how important these assignments actually are. I'm not able to download anything live right now, but you should be cognizant that you should probably take a look at the first assignment because it does have some programming already in it. Each one of these assignments has a little bit of programming, some written parts to it, etc. Darn it, I did not load the syllabus. That's okay. We can load the syllabus up here anyway. If you just bear with me for a second here. Documents, syllabus, and Markdown, toggle preview. Let's open this up in a new window. Now, usually this is going to be hosted on GitHub, but of course, since we don't have access right now, you'll have to check this out later, but here it is. We'll go over the syllabus here as well as the policy and stuff like that. I just gave you that preview of what your next 15 weeks is going to look like. It's going to be 10 different homeworks, 1 due about each week. So what is this? First of all, I like to open up with, you know, a theme of the course. And of course, this is a kind of old cliche almost at this point that computer science is no more about computers than astronomy is about telescopes. Hopefully you'll understand by the end of this course that what computer science actually is. It's a branch of mathematics, actually. In fact, historically many computer science departments grew out of the math department instead of engineering departments, right? And now they're stuck in between, you know, somewhere in between. We're stuck in between. We're hopefully going to have a school of computing soon where we'll be able to distinguish between all of those things as its own entity, right? When something new is born, you always, now we're talking about, you know, 60 years ago when modern computing was born. then you always try to associate it with something that already exists rather than recognizing it for what it is, something brand new that's not really comparable to anything that came before it. And that's what computing is. But it's no more about computers, in other words, the tools that you use, than it is about telescopes and the tools that astronomers use. And then I also wanted to bring your attention to the second one, which is actually more specific to this course, in my opinion. That if you want to be a good programmer, you can program every day of your life for 2 years. If you want to be a world-class programmer, you can program every day for 10 years. Or you can program every day for 2 years, like you may have been doing already now that many of you are sophomores, and take an algorithms course. Algorithms and data structures course is what I would say there. And that's what this is, right? At the conclusion of this course, you'll be able to have an appreciation for the different styles of algorithms. You'll have strategies and stuff like that. You'll start to see the world as everything is divide and conquer kind of approach to everything. You'll be able to look at your toolbox of data structures and say, I can just pull out this data structure, modify it a little bit, and the problem is solved and I'm done, right? I didn't even have to solve that problem. There's a pre-existing data structure that did it for me and does it efficiently. Right? The prerequisites for this course are CS2 and discrete math. And we will assume that you've covered everything that's in the course specs for those courses. We'll go over that here in a moment. But here's the full description taken from the catalog. Read that at your leisure. The textbook is only recommended. It's Leviton. I don't know what edition they're on. It doesn't really matter. They don't really change the editions. You can find this book pretty easily without having to pay for it, hint, hint, if you really want it. Otherwise, I've got an extensive note set, lecture note set here that's linked here. It's a rather large PDF, 300 pages or so, and I'll be working off of that. As I work off that, and if I do anything that's not in that lecture note set, then I'll add it and push it out to GitHub, and then you can just refresh. Actually, it's on Bitbucket, not GitHub. Otherwise, if you're looking for a more, refined, I guess, highly edited textbook, OpenDSA, that's Data Structures and Algorithms, is an online textbook that also has a bunch of pictures. I think they might even have interactive stuff. It's not that great, but I'll use different interactive stuff as we go through the semester to visualize some data structures, visualize some algorithms as we go along. Otherwise, Algorithms by Jeff Erickson is also another free online textbook. Those are just all recommendations, okay? You check them all out. Look up each topic as they're covered, and I like OpenDSA's take on balanced binary search trees more than I like Burke's note set or whatever. That's fine. Just go ahead and read that for supplemental material or ahead if you want to. There is a post-requisite here that if you are a computer science or computer engineering major, you will need to receive a C or better in this course to continue in the major. Good news is that everybody that took the summer course that did not withdraw met this minimum standard over the summer, and as an honors course, I expect that to be the case here too. All right. So there's my take on the course overview, basically encapsulated with those two quotes before, that it's really more about computing, problem solving, than it is ever about computers. Okay. The topics and schedule, again, see Canvas here. These will be updated as these are pushed out to YouTube. Hopefully, if we're live streaming the next time we meet, then it'll automatically be there, and I will just cut and paste a link for each one of these days that we cover, okay? But otherwise, you can see here, generally, we're going to follow kind of the pattern of Leviton. We're going to cover brute force algorithms, then divide and conquer style algorithms, greedy algorithms, data structures, et cetera, as we go all the way through here. There is a midterm, that's just a copy paste error. Again, there are no exams for this course. All right. So the course delivery, unfortunately, when under ideal circumstances, when we have actual network, then they will be live streamed on my YouTube channel. The recordings of the lectures will be available immediately afterwards. This one, of course, will be available 8 hours afterwards, maybe, and once I get home and I have some network. During the live stream, under, again, ideal circumstances, I will have my second computer over there open to the live Q&A on Piazza that you should have all been invited to. Hopefully you've accepted those invites. If you feel like, if you feel brave enough to raise your hand and ask a question, perfectly fine, great. But if you're attending remotely or you're not brave enough and you just want to go ahead and type out your question, I'll see it over there. Right? Written solutions must be submitted through Canvas as PDF files. No hard copies are accepted. So the written parts that you'll write up, you can go ahead and write them by hand if you want to, and just take a series of photos with your phone or scan them or whatever you want, right? As long as they're PDF files, you can go ahead and submit them through Canvas. Right? And I won't go through that again because I don't have connection here. But you just drag and drop a PDF folder. If you need some tips on like apps that will convert a bunch of images to package them up into one PDF, I'm sure that you can post on Piazza like, this is what I'm going to use, and here's a free app or something. Right? Otherwise, all coding artifacts, including test cases, scripts, and your actual code, that'll be handed in through the web Handin. Right? So anybody not familiar with the web Handin system? Okay, so unfortunately, I'm not going to be able to do it today, but you'll go to cse-apps.unl.edu/Handin. That link is available on Canvas here. Let's see, where is it? So there's web Handin. Once you go there, you can go ahead. I can't do it now, but you can drag and drop files. Once that's in there, then you can go ahead and come over here to the grader, and you can grade. I've got all the assignments here already set up with grading scripts. I have not troubleshot them all, but I have used them before. So if you see any issues, please let me know immediately. But otherwise, what you can do in this first week is do that Hello World program. That's just to get you set up with the process that I'll talk about here in a second, because I do not require any specific language. You can do this in any language that you want except Java. I highly recommend you not do it in C. I highly, highly recommend that you do it in Python 3. In fact, all demonstrations that I'm going to do in class are going to be using the Python 3 language. So if you know Python already, great. If you know Python 2 but you don't know Python 3, not so great. Make sure that you are learning Python 3 and the small little differences between the two languages, because I believe Python 2 has reached the end of support. Yes? No? I don't know. Anyway, always go with the newest one anyway. And we'll talk about Python 3 here in a moment. But otherwise, what you do is you hand in a script that specifies how your script or your program is compiled and run. And that way, as long as you hand in that one script that has to be named run.sh, then you're good to go. If you go to the GitHub repo for this course, I have at least a dozen examples of those scripts. So if you want to do it in C#, I've got one for that. If you want to do it in Node and JavaScript, I've got an example for that. But again, I can't get to it right now. All right, so back to our syllabus. Any questions so far? No? Okay. All of my office hours, unfortunately, I only hold 4 a week, Monday and Wednesday, and that's on the, it should be up here. My office hours are Monday, Wednesday, 2 o'clock to 4 p.m., only via Zoom. Now, when you go into the Zoom link here, that's the same Zoom link that I use for all my other courses, including Computer Science 1 and Computer Science 1 Honors, which have about 20 LAs associated with it. So it's like going to be going in, there are only 10 folks that are enrolled in this course, but you'll be going into this large Zoom room. Just go ahead and find me and wave me down, right? I'll know that you're there, right? Somehow, we'll figure it out. But otherwise, there's my YouTube channel. If you want to, I've been recording or streaming this course now for at least the last 4 years. So if you want to take a look at like an old video from 3 years ago, whatever, then it's available there. Otherwise, there's my live link that would be live right now, and then there's the playlist that I will add to as we go along with each one of these recordings. There's Piazza, our online discussion forum. the Handin, the grader, a bunch of department resources as well. There's an anonymous feedback form if you want to contact the department for anything. If it's pertaining to this class, you can go ahead and say so, and you're completely anonymous. There's our academic integrity policy, our account management system. So if you do not have everybody has their CSE account? Yes? No? If no, then go to this link as soon as possible, grab your account. That's the account management, and you'll give your Huskers email, and then you'll get your credentials. You will need that for the Handin and the grader. Otherwise, there's a system FAQ. There are my lecture notes again. And in addition to those open source textbooks that I mentioned, Coursera also has an Algorithms and an Algorithms 2 course. I think, at least last I checked it, they do require a credit card for even the free stuff. So don't quote me on it, but it's not as good as it once was, because at least you could get access to all the material and watch their videos and read their handouts or whatever. They really only used to force you to pay for something once you wanted credit for it, or the certificate, or whatever the hell they gave out for it. Those may or may not be good. If you're already part of Coursera, you could probably get access to it. If you want to learn LaTeX for this course, go ahead. Great. I encourage you to do so. And there are some things getting started with LaTeX. LaTeX is a typesetting system for doing a lot of math stuff. You do not have to use LaTeX for this course. If you want to learn it as you go along to add that skill to your toolbox, great. Go ahead, and I will answer any questions that you might have about LaTeX. But it's not required for your assignments. You can go ahead and write them out by hand if you want to. If you can go ahead and put them into Word if you want to, but I would highly recommend that you don't do that. All right? You are going to spend 10 hours just getting Word to format stuff. You could have spent that 10 hours to learn LaTeX and not have to worry about that ever again for the rest of your life. But anyway, those are the resources. COVID considerations, again, as per this is just UNL policy. If you are not fully vaccinated, you have to wear a mask. If you are fully vaccinated, we still strongly recommend that you wear a mask. Now, in this class, it's not that big of a deal because we can spread out. There's only 10 of us here, and 1, 2, 3, 4, and 2 of us are missing. It's not that big of a deal in this class, but it's still a good idea because you don't know about the person next to you. You don't know, it's a good idea. Right? You can see it's a good idea. It's such a good idea that I'm doing it. Right? All right, so accommodations for students with disabilities. If you have any accommodations that you need, make sure that you are getting registered with the SSD office. With the absence of exams and quizzes in this course, I anticipate there won't be much need for accommodations. So instead, but if you do, then make sure that you're talking to them. There are also COVID accommodations this semester. For example, if you test positive, or you're barred from the building by the gatekeepers out there. Of course, the accommodations are you can watch this stuff on my YouTube channel after the fact. Right. There it is, 10 assignments, each worth 100 points, 1,000 points total. That's it. No late work is accepted. Make sure that when you hand a program in that it actually works. If it doesn't work, I'm the only grader. Right now, I'm the only grader. I'm going to move on, right? I've got 2 other classes with 250 people in them right now. So make sure that it works, make sure that it runs on the WebGrader and that it runs consistently on the WebGrader. Make sure that your PDF is not corrupted, that you can actually view it once you upload it, make sure that you can actually view it. The way that I'll grade that, of course, is by marking the PDF in Canvas so you can see the immediate feedback there. Right? Basic letter grade distribution right there. Right? You need at least a 73 in order to go on in the program if you're a major. The majority of the assessment, in fact, the 100% of the assessment, is based on a series of assignments that consist of both written parts and a substantial programming part. You saw that there were about a dozen programs on that WebGrader. So there's 1 to 2 programming exercises on each assignment. Keep that in mind. No late assignments are accepted. Programming solutions have to actually work. Don't steal code, et cetera, et cetera. No exams for the course. Yay. Grading policy, if I had a grader, and I may end up getting a grader, I'm not sure yet, or somebody to help me with it, then you have to address questions about grading to them first, but of course, since that's me, just come to me. No late work, of course, web grader policy, academic integrity. On all of your homework assignments, it must be your own work. This is just the blanket statement here. But if you take a look at the assignments, once you get your Wi-Fi back, you'll see that you can work in pairs. Not groups of 3 or more, but pairs. You can always work alone if you want to. But if you want to, you can go ahead and pair up with somebody. If they flake out or whatever, or then you can go ahead and change up partners throughout the semester. I don't care. That's between y'all. But you can team up with one other person and turn everything in as a pair. If you do, you're going to have to go into Canvas and indicate that by signing up for a pairing. And again, I'm not going to be able to show it to you. But there will be like assignment pairs under people. Go to people, and then there's like groups, and each one of you can join a group, and you turn in one PDF, you turn in one copy of your code, and you get one grade for all of that. Right? The enrollment is much smaller in this section as an honor section. Note that there are 2 other sections. It looks like the time works out for everybody here. But if the time doesn't work out or you need to shift things around, there are 2 other sections that meet. I have no idea when. They have plenty of seats available though. Right? One of the differences was, of course, much smaller here. I think that they have 30 each, and we only have 10 here. There is no recitation session for the honors section. In recitation, you would usually use that for recitation, right? Where you are going over the problems or going over extra stuff, or administering a quiz because you don't want to take lecture time to do so or whatever. As an honors course, for that extra practice, that falls to you as honors students, right? If you need that extra practice, then it's on you to get that extra practice. If you want that extra reading, it's on you to find that extra reading and do it, right? But otherwise, it's your responsibility to get that extra recitation kind of benefit. We will cover topics at a slightly greater pace so that we can introduce some advanced topics. One that I already know that we're going to do because you have a programming assignment on it is talking about public key cryptography, RSA specifically. And you will be breaking this public key cryptography and decrypting a super secret message, right? I forget where that is, but it's like the 4th homework or something like that, right? Or maybe the 5th, I'm not sure. But then throughout the semester, we'll also do some extra stuff. Or by going faster, maybe we can take off that midterm day, or the Monday before Thanksgiving, we can blow that off or something like that by going faster. Let's see. I have my own anonymous suggestion box here. If you want to send it to me directly, you can go ahead and use that. Otherwise, the department maintains that one that we talked about already there. Right. The best way to get help is, of course, to post to Piazza. Primarily listen to and watch the lectures. Piazza office hours, if you have questions. You could probably attend the office hours of the regular section, and they'll be none the wiser if my office hours don't work out for you. Otherwise, again, as honor students, you're resourceful, right? I'm sure that you'll be fine. Don't procrastinate. You've all survived now at least a year of college. You know what it's like. You know the story. So if you start late, you're probably not going to do well. Right? Get help the right way. This is something I put in all of my syllabi. Don't just say, "Oh, it doesn't work. I don't know what's going on." You have to tell me how it doesn't work. You have to tell me what have you tried so far, right? You have to be specific, right? I had a CS1 question just the other day. Like it doesn't GitHub is not working. Like, okay, I don't know how to answer that. Like, how is it not working? Well, I checked github.com. It's up and running. It looks like it's working to me, right? You have to be a little bit more descriptive than that. Get help the right way. Any questions about the syllabus? Otherwise, I tried to keep it as simple as possible. Okay. All right. So that's what this course is about. what might you need going into this course? And I'm definitely going to go over the prerequisites here because it was brought to my attention that, at least in the summer session, that many people had maybe a discrete math course outside of the university or at this university where they didn't cover everything because of the 14 weeks or something like that. Let me know if that's the case so that we can reiterate some stuff. Yeah?
That is the case for me.
Okay. As we go along, when we hit those topics, let me know and we'll do a little bit of a review since we have plenty of time. For example, at least what I was told is that they didn't even get to graphs. Okay, fine, whatever. So what you need are these basic skills, right? From Computer Science 2, Computer Science 1 by transitivity. You covered transitivity in 235, right? A to B, B to C, therefore A to C. All right, good. So by transitivity, you should have proficiency in at least 2 programming languages at this point. Again, you can use whatever programming language you want for the assignments. I highly, highly recommend that you use Python 3. Right? You are not allowed to use Java. If you want to make your life super, super tough, I would say use C or C++. But I think that you probably want to make your lives a lot simpler. How many people already know Python? 3? 3? Okay, hopefully 3. Did we learn on 2 and then we went to 3, or did we learn on 3? 3? Okay, 3. Okay, good. It's good to know that the 2 to 3 crowd has been moved along. Anyway, basic searching and sorting algorithms. We're going to assume that. Basic algorithm and algorithm analysis. The 5-step process of you identify the input, you identify the input size, you identify an elementary operation, you analyze the algorithm with respect to that elementary operation, and then you provide a big O analysis of it. We'll go through that if we have time today. Yeah, we've got 20 minutes left. Basic proofs and logic, right? So proof by contradiction, I'll use that throughout the semester if we do proofs. For this course, by the way, I tend to emphasize more the practical side rather than the theoretical side. So far fewer proofs, far more programming, right? When I took this course, or some instructors don't even have programming for their data structures and algorithms course, which I think is a huge shortcoming, but the vast majority of them do. I emphasize more the practical side of stuff rather than the theoretical side of stuff. Basic combinatorics, permutations, combinations, right? Hopefully at least my son is in 7th grade, and they started they did some of that stuff at the tail end of 6th grade, and I assume that they're going to do more in the 7th grade. So that's also, primary school stuff, right? Permutations, 3 people, how many ways are there of arranging them in a row? 5 people, how many ways are there of choosing 3 of them for a subcommittee? Right? Combinations, permutations, order matters, order doesn't matter, etc. Okay. So given those basic skills, what I want to do is I want to do a review and a motivating example. All right. So, by the way, these will be pushed out to GitHub eventually. You should take notes, because the very act of taking notes as you're watching something drives it into your brain. It's been proven by psychologists, I think, maybe. At least that's what they say, right? So here's the problem. You might have seen it before, that given a set of points in the Euclidean plane, determine which pair is the closest. Okay? So to understand the first step to any problem, to solving any problem, is what? Is it already solved? That's an excellent engineering question. Bear with me since it doesn't recognize my face because of the mask. But the first step is to understand the problem, right? So what are we talking about here? We're talking about, there are a bunch of points in the Euclidean plane, right? And there's a certain distance between each one of these points. How do you measure distance in the Euclidean plane?
Distance formula.
Distance formula, which is?
X squared of x squared plus y squared.
X, the difference of their coordinates, right? Because this is x1, y1, and this is x2, y2, right? All pairs have 2 coordinates. So this square of differences, right? And then you sum them up. x2, or sorry, y1 minus y2 squared. There we go. There's the distance formula. So how do we go about solving this? Well, there's these two, right? There's some distance there, but I also have to consider these two, and there's some distance there. I have to consider these two, and there's some distance there. If I go through every single possibility, and I compute the distances for all of them, and I take the minimum one, then I've solved the problem, right? So how do I go about doing every single, what do we call these things? I want this one and this one. I want this one and this one. I want these two. I want those two. I want those two. There. Not permutations, but pairs, which would be combinations of size 2, right? How many are there, by the way? So this is one of those review things, right? Given a set of n distinct elements, how many combinations, that is, order does not matter, order didn't matter, right? The distance from this point to this point is the same thing as the distance from this point to this point, correct? So order does not matter. How many, given a set of n distinct elements, how many combinations of k elements are there? So this is more general than just pairs. How do we compute that? N, choose, okay? There are several ways of writing this. The mathematically correct way of writing this is n choose k, right? If you look on your calculator, you will not find something like that. Instead, you'll find something like CNK or CNK or NCK, something like that, right? Et cetera, et cetera. Right? So, what is n choose k? Do you know how to, there's a closed form formula for that. What is it? Don't remember?
N factorial times n minus k factorial.
In the denominator, yes, that's where it goes, and then k factorial in the denominator, right? So for our particular problem here, of all of these points, we're looking for pairs. So for example, n choose 2 will give us the number of pairs of points, where order does not matter. Point 1 and point 2 is the same thing as point 2 and point 1. So let's go ahead and expand this out. What is it going to be? N factorial over n minus 2 factorial, which is equal to, what happens to all these n factorials and n minus 2 factorials? What survives? N times n minus 1. All the rest cancel. All over 2 factorial, which is just 2. Right? So immediately, even before we start solving this problem with an actual algorithm, if we do this, basically what we're doing is brute force. We're trying every single possible pair. Then this is going to be order what? What's the most important term in this expression right here? N squared, right? Because minus n squared, all over 2, all over 2. We don't care about lower order terms. We don't care about constants. What do we care about? We care about the highest order term without those constants. So my approach immediately here is going to be kind of bad, and you're going to see why, right? For a lot of inputs, it's actually going to look good, right? So we're not going to be able to get to it today because we're going to have to solve the problem and then we'll program it. But Let's go ahead and start by solving the problem. So I'm going to write some good pseudocode here. Good pseudocode clearly labels the input, clearly labels the output. Right? The input here is, well, it was as described, right? What was it? Given a set of n points in the Euclidean plane, determine which pair is the closest. So my input is going to be a set of points, 2D points, whatever, right? X1, Y1, oops, dot, 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 Xn, Yn. And by writing that, I've already solved the first two steps of algorithm analysis. I've identified the input and I've identified the input size. What is the input size here? N, the number of points, right? Now you could say, well, wait a second, each point has two numbers, right? So is it 2n? No, we ignore those constants in the end, so let's simplify it and just n, right? It's n points, it's n things. Those things happen to be made up of multiple things, but those multiple things are just a constant. Right? My output will be, what do we want it to be? The distance or the two closest points or what? The 2 points? Okay. The two closest points in A. I like that. Who said, I can't see mouths moving, so. All right, why did you go with 2 points instead of just the distance?
That's just how like the question is phrased.
Oh, okay, good. That's what you asked for. Duh, right? But also because from a design point of view, if I gave you the 2 points, could you find the distance? Yeah. If I gave you the distance, could you find the 2 points? Not very easily without having to resolve the problem, right? That's actually a very, very good, very, very proto introduction to what are called reductions that we'll get to by the end of the course, right? Can I use the solution to one problem to solve another problem? And if so, then there's a very close relationship between those two problems. One problem reduces to the other problem. Right? And that's how we establish relative complexity of problems, and therefore how we can establish what are called complexity classes, P and NP, if you've heard of that phrase before. Right? All right, so the two closest points in A. Good pseudocode. For each pair. I'm cheating, right? I don't know how to write that. I don't know how to write code to run over each pair. I do know how to write the English, though. For each pair of points, I don't know, XA and X, or sorry, let's rewrite that. XA, YA, and XB, YB in A, do the following. In fact, that's a little bit too Pythonic. I got in the habit there of putting in a colon, which is what Python does. All right? I'll leave that off. What do I want to do? Compute the distance. Using that nice formula that you gave me before. XA minus XB squared. YA minus YB squared. Add those together, take a square root. Nice pseudocode. Why? I'll bring your attention to a couple of things here. Liberal use of mathematical notation. I did not write math.sqrt. I did not write math.pow or anything like that. I wrote the true math in this, right? Because it's pseudocode. I didn't use an equal sign as an assignment operator here. Not all programming languages do that. The vast majority of them do, and I wouldn't fault you for doing it, but I'm using this left arrow right here to say that take this thing and put it into this variable right here, right? There's been a constant controversy in computer science education that people don't A is equal to 2. That syntax is it's wrong, of course, because a single equal sign in mathematics already has a well-defined meaning. It's equivalent to equals, right? But computer science education theorists will say we shouldn't. That's what trips people up. Like, now, once you get past the idea, and once you understand that you're taking the thing on the right-hand side and putting it into the variable on the left-hand side, it's pretty straightforward, right? But the arrow, I would argue that that's way clearer. Put that thing into that thing, right? And that's what I'll use for my pseudocode, right? Now, I've got the distance of that particular pair. If that distance is smaller than the distance I've found so far, then I update it, right? If that distance is less than the min distance, then I'll update min distance. And since we chose to output the points, I'll go ahead and put in that PA and PB, oops. I'll go ahead and assign, I'll give these names here, P1 and P2. P1, P2. Right? Instead of having to write 2 lines, P1 is equal, or PA is equal to P1, PB is equal to P2, I'm just going to write that in 1 line. And guess what? Python, you can do that. Cool. Right? I'm not going to use opening and closing curly brackets. Instead, I'm going to use these vertical lines to indicate blocks of code. Why? Because not all programming languages use curly brackets. For those that already know Python, Python doesn't use curly brackets. What do they use? Indentation, right? And woe be to you if you take it from one editor to another editor and it has different default indentations. Right? And then it's all cut and paste and it's all over the place and you've got to go back and fix it. Right? Okay, there. After I've tried every single possible pair, I will simply output P sub A and P sub B as my pair. I left some room up at the top. Why? Where do I start? That first point is going to have a distance. Am I going to have a min distance to compare it to? Nope. So what should I start out with? What value? Or the maximum representable by whatever programming language you're in. If you're programming it, I'd say yes, but I'm pseudocoding it. What is guaranteed to be larger than any other finite distance? Infinite, right? And you could also do that in a lot of coding languages too. Python, you could do that. Math.inf. Right? Excellent, all right? Then if you want to go back and format it 1, 2, 3, 4, 5, 6, 7, whatever. As a first step here, before we move on and actually analyze this, translate this line here for me for each pair of points. If they were actually stored in a list, how would you iterate over all possible pairs? For I equals 0, I is less than n, I plus plus. Okay, and then an inner for loop for j running from, I'll start mine at I plus 1. Why? A, B is the same thing as BA. Right? So there's no point in starting back to where, things that you've already looked at. I is less than n, or j, sorry, j plus plus. And that means that I can stop short here at n minus 1, right? Dot, 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 right? So that would be the traditional idiomatic for loop for achieving this pseudocode right here. Pythoners, what would it look like? Actually, yeah, that's how I would do it in Python. Pythoners here for just a regular old for loop for x in a, it would look something like this. But if you tried to go for y in a, now you're iterating over all pairs, including things with themselves. If I've got this point and I compare it to itself, what's the distance? 0. Is that what you want? Nope. So this is the way I would actually do it in Python as well. Right? There might be some cool trick that you can pull, but whatever. All right, so let's go ahead and analyze this. And to do that, I'm going to go ahead and get rid of my notes over here. Step 1. What's the input? Clearly written pseudocode should already have that for you. The set of points, A. What's the input size? The number of points. In this case, clearly written pseudocode tells us that there are n points here. Right? What's my elementary operation?
Comparison?
Okay. One candidate would be the comparison right here. You wouldn't be wrong. Is there another just as right candidate? All right, the calculation of the distance as a whole. Good. Or you could, focus in even on that. Among all those arithmetic operations there, what's probably the most expensive? The square root, right? Because that's going to take some interpolation method. Or you could say that it's multiplication. Or you could say that it's addition, in which case there are 3 there because subtraction is addition by a negative number, right? None of those are wrong, but they all lead to the same answer, right? So I'll go ahead and go with the comparison since that was the first one that was said. The comparison on line 4. Right? Now, how many times do we execute this comparison with respect to the input size? I execute it once every time we go through this loop. How many times do I go through that loop? We already did it, right? How many pairs are there? N times n minus 1 all over 2. And then we've already done step 5 here. Provided asymptotic characterization for it. So step 5 or 4, it's going to be n, choose 2. I'd prefer leaving it in that form. Right? There's no reason to expand it out. Right? If you were doing something where you iterated over all triples, n choose 3. Right? If you were doing something where you iterated over all subsets, 2 to the n, right? And this is going to be 5. It's order n squared. Right? Did you talk about theta? That's even more right? So big O is loose, right? That I can say that n is big O. You talked about this, hopefully, right? You can also write n is big O of n, right? That's an abuse of notation, but it's so common that it's okay, right? It's kind of like a bad grammar that then becomes part of the lexicon. Now it's no longer bad grammar, right? Because everybody says it. All right, so this is order n, but also n is order n squared. That's also true. N is also order 2 to the n. Right? But which is the most helpful statement among these 3? The first one. And that's a tight characterization. And theta gives you a tight characterization from both below and above. Okay? Another way of analyzing this would have been to actually write out the for loops for I running from 0 up to n minus 1, for j running from I plus 1 up to n, right? Dot, 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 doing whatever you're going to do in there. You do it once here. How many times do you execute that one line? Well, you run it for j from I plus 1 up to n. And how many times is this inner for loop executed? It runs from I equals 0 up to n minus 1. And then you solve that closed form solution using something that hopefully you'll memorize at this point. I is equal to 1 up to n of I. 1 plus 2 plus 3 plus 4 plus 5 is equal to n times n plus 1 over 2. Not the same thing as n choose 2. It's just the difference of a plus here. And this is old Gauss's formula. Because ultimately what you'll do is you'll get this into a form of I equals 0 up to n minus 1 of, and then how many times, this is easily solved here. It's going to be I plus 1, I plus 2, I plus 3, all the way up to n. So it's actually going to be n minus I. You split that up into 2 summations, which we're not going to do because we only have 1 minute left. One of them is easily solved as n squared The other one is half, you subtract off half as much as the first, giving you this final solution right here. Okay? So for next time, we're going to have some internet connection here, and we're actually going to program it. So again, how many people know Python 3? 1, 2, 3, 4. I would encourage, so it's okay to use Python 3, especially if you've not had a lot of Python 3. But I would encourage you to try another programming language maybe, or mix it up and do one in Python and then another in JavaScript or C# or something like that. If you don't know Python 3, then I would encourage you to pick that up as an added skill for this course. Okay. All right, again, this will be posted on YouTube later today. I just have to stop recording.